Good morning, good afternoon, good evening, everybody, wherever you are in the world. A very warm welcome to everybody present here. So, today we are going to talk about Envoy AI Gateway and see how it can help to contain AI sprawl. So, my name is Bhavishya Gupta, and I'm joined by my awesome colleague Anmol Sachdeva. We both work at Google and we are senior cloud architects over here. Okay, so before moving forward, I would like to call out a disclaimer. The content and views presented during this talk are our own and not representative of any organizations we are associated with or employed at. Okay, so let's jump into the flow of the talk. And it is as follows. We'll see some of the key challenges which organizations face while serving AI LLM workloads. Then we are going to get introduced to the Envoy AI Gateway. We'll then delve into a live demo showing GenAI traffic serving using Envoy AI Gateway. And finally, there would be some highlights on the key takeaways from the talk. Okay, so before the AI Gateway, managing GenAI traffic was a pure chaos. So the root cause of this chaos was that every developer, every app, every model means a new key. So this was a breeding ground for API key credential leakage, and that is a massive security risk. So the chaos even extended into model delivery itself. We are dealing with model mayhem, inconsistency, and vendor lock-in, leading to inconsistent security policies across different providers. Next, we'll hit the wallet. We face token bill shock and unpredictable cost. Why? Because we have a lack of unified access control and zero visibility and observability into the consumption. If we do not know who is using which model for how long and for how many tokens, we really cannot predict our budget. And this leads directly to due to lack of governance and makes difficult in auditing usage and compliance. Furthermore, we lack fundamental reliability features like no automatic failover or circuit breaking. This pushes the burden onto the client application to handle retries, resulting in inefficient and unreliable routing. And finally, we face the integration hurdle due to inconsistent request and response data formats. Because as we know that every LLM provider or even different models within the same LLM provider use slightly different schemas. And this forces developers to write some bespoke code and adapters for every model they want to use. And this is slow and expensive. Now, this whole chaos, marked by security risk, bill shock, and unreliable routing, is a AI sprawl that halts enterprise adoption. Sorry. The Envoy AI Gateway is a simple solution which will help us to solve this problem. So, what exactly is Envoy AI Gateway? It is a first and foremost an open source project driven by a strong community. It's built on Kubernetes Gateway API, extending the mature high performance Envoy proxy, which powers the seamless handling of GenAI traffic. Most importantly, it provides a unified control plane. This eliminates the sprawl. Platform teams can properly define security, routing, and cost policies in one place, regardless of where the model is hosted. AI Gateway supports multi-model and multi-cloud reality. It supports 15 plus AI LLM providers. For those with latency sensitive workloads, even self-hosted models are equally supported. This gateway delivers rich observability. We're not just seeing like error codes 200, 400. We get a detailed insight into token consumption, time to first token, and user quotas. Finally, none of this is possible without the people behind it. This project is backed by a flourishing community, constantly adding new features. So now to dive a little more deep into the technical architecture, I'll pass on to my co-speaker Anmol to take it forward. Over to you, Anmol.
Sure. Thank you, Bhavishya. Great introduction you did. So first, we will understand the kind of high-level arrangement of different components in the AI gateway. we specifically have a distinct control plane and distinct data plane. This is essentially to maintain reliability, also to have flexibility to be able to scale components independently. Specifically for the control plane, we are leveraging the Envoy gateway itself. And then for the data plane, we are using Envoy proxy. But then there are some additional components added in the control plane and the data plane to make the AI gateway possible. So this is where, at a high level, the architecture uh, like a diagram looks like. The first one is the control plane that you see at the top. This is where you first have Kubernetes API server through which you are getting the configurations. In this configuration, you have any kind of YAML, let's say some gateway route, some backend route related or backend TLS policy related configurations. These configurations are gateway API configurations or Envoy gateway resources, which are populated to the Envoy gateway controller. Meanwhile, there is a separate component which is AI gateway controller, which is also getting these resources, the AI specific resources, to be very precise. These AI gateway resources could be abstract configurations which the users might have fed in order to make sure that the abstracted configurations or manifests are able to map to what Envoy can understand. We have this AI gateway controller further expand those resource configurations into what can be comprehended by Envoy gateway controller. And then these modified or abstract configurations that are expanded into their equivalent forms are essentially communicated back to Kubernetes API server, through which Envoy gateway controller really sees that, okay, these are the lower level configurations that have to be applied. Ultimately, there is a discovery service also, which is running in between. So discovery service is the regular discovery service you could be having for listener, for routes, etc. uh, all these coordination really helps get to the actual configurations that should be applied and that should be governed for the data plane. So this is where the Envoy gateway controller updates the configuration in the Envoy proxy. You also have two additional components sitting here. One is the rate limit service and one is the external processor. Specifically talking about the rate limit service, it is also backed by Redis. So you have some sort of that is getting stored in the data store. The external processor is what is actually a sidecar, and this gets the configuration from the AI gateway controller. It's essentially the AI external processor wherein the main AI related logic execution happens. So at a high level, this is how the control plane and data plane structuring is like. To delve one level deep, we actually get into the internal of how the control plane works. So this is where at the top you see we have the user applied resources. These resources are nothing but the Kubernetes manifest, your custom resources that have been deployed. Now, the standard gateway backend resources that are there for the Envoy gateway will directly communicate with the Envoy gateway controller. They will also be getting watched by the AI gateway controller so as to see whether there are any corresponding configurations that are to be respected. And then, meanwhile, there are different set of dedicated AI gateway resources like AI gateway route, like AI service backend, like the backend security policy. Likewise, there could be some additional resources that you might have to deal with when you get into things like inference pool or MCP configurations with Envoy AI gateway, which, given that this is a very beginner friendly session, we are not going to cover. And specifically in the Envoy AI gateway controller, since we have got these configurations and resources, the spec for the same, we now have the abstract resources expanded into what can be comprehended by an Envoy gateway controller. So this is where you see the equivalent or corresponding HTTP route, the filters, and the corresponding secrets getting created. Now, this particular secret is essentially created by the Envoy AI gateway controller, which is populated to the sidecar in the proxy pod. So this particular sidecar is the external processor sidecar. These secrets are essentially leveraged to communicate with the Envoy proxy so as to maintain the internal trust and authentication. And behind the scenes, as we expanded in the previous architecture, you can see that this extension server protocol is getting used. This is essentially for the fine tuning purposes that I talked about. And all the injections that are happening with respect to external processor are using the Kubernetes admission webhook controller behind the scenes. Coming to the data flow, this is quite straightforward and intuitive. You have a client which is, let's say, an OpenAI client or some SDK for Vertex. Let's say you are making a request to the Envoy proxy, which is the actual serving path. Envoy proxy takes that request and gets to the external processor. Now, external processor extracts some specific fields like model name, any specific headers that could influence the behavior of the execution. You have the same acknowledged, and Envoy proxy then goes ahead and checks whether any rate limit is getting hit using the rate limit service. Rate limit service is an optional one. You can even skip that deployment as part of the actual provisioning of Envoy. And then ultimately, once the checks have been done, you get into a loop. Generally, it's a retry or feedback loop if you have any fallback or retry logic executed and specified as part of your configurations. And specifically here, you go ahead and have the upstream external processor request. This is where the actual proxy execution will happen. This request will then be acknowledged and will be then forwarded to the AI upstream. Any kind of authentication that is happening with the upstream is also taken as part of this particular flow. Once the AI upstream provides the response, then you just go ahead and have the response modified. And as part of the modification, you also tap on the token usage and update the metadata in the Envoy proxy. And then ultimately that is adjusted against the rate limit. So this is how at a high level works. These are the resources as to how, in a hierarchical fashion, they are inferenced. So the AI gateway resource references the backend resource. Now, this AI service backend is corresponding to a single upstream AI provider. As Bhavish mentioned, you can have self-hosted or you can have the ones provided in public. And then ultimately, these could be referencing the service backends in Kubernetes or could be having security policy for API key verification or authentication exercise. Now we'll come specifically to a quick demo. This is where we have already deployed the Envoy gateway system. So I'll just show you show first the sources that are deployed. You can see that already I have the rate limited part. I have the service exposed specifically for the default AI gateway. This is exposed over some external IP. And I do have another namespace, which is essentially having the AI components. And this is where you will see a pod, which is the AI gateway controller, the main controller, which is helping with the proxy execution for the AI logic. And using this, I have actually already deployed a simple self-hosted model. And this configuration is something that we have the link to in the deck. So this is where it's like just we are using a self-hosted model. It's a regular Kubernetes cluster, nothing fancy. You can even do this on a current cluster. So you see already that the self-hosted minimalistic model is giving us different responses based on the common prompt that we are giving. So ultimately, coming to some of the key takeaways, given that we are towards the last leg of the presentation, first thing is that don't treat your applications as the place to implement your AI logic. Delegate that and decouple that logic for AI processing to your AI gateway, like authentication, rate limiting, any security enforcement that you need to do. You need to understand that AI models are pretty unpredictable. So the AI gateway actually gives you control to have model routing and circuit breaking exercise. This is where you can not just focus on the 5xx errors that are emerging from the upstream, but also you can do routing based on cost getting incurred, token usage, headers, or any latency getting incurred. So if, let's say, Vertex is taking some more time to respond, you can actually switch to or fall back to Anthropic. Then the AI gateway resources can be very well managed with GitOps, Argo CD, or any other Flux CD related GitOps pipeline do work. So go ahead and make use of them. Enforcing MTLS within the data plane is pretty necessary. This is to ensure zero trust within the data plane as well. So that's a good practice. You should be focusing on having different tiered fallback strategies. These are what you can implement using the AI service backend resource that I mentioned, and then have them configured in the route. This is again based on different cost or latency related factors. And then ultimately, as we discussed during the introduction, MCP and inference pool related support has been introduced. So go ahead and try to explore those kind of resources. It's pretty rich in terms of functionality. So with this, we just wrap our introductory session to how the Envoy AI Gateway works. In case you want to connect with us for deep dives, feel free to connect with us on Slack, or these are our coordinates which you can connect with us on. Thank you, everyone.